So, as I hope you remember, we are having our first test on Friday, and I thought maybe we should talk a little bit about the test. We can, if you want to, like spend the whole time doing review problems, although I hadn't planned on doing that. But I figured we'd just talk about it for as long as you want to talk about it, and then we can go on with the derivatives stuff, which is what we've been talking about lately. The derivatives will not be on the test. But anyway, I will try to describe what I think the topics are going to be. Exam 1 basically covers everything except derivatives. Everything except for the very latest stuff that we've been talking about. More concretely, everything on all the homeworks, number 1 through number 5. Homework number 5 is due today. I hope you've had a chance to look at it. And what this consists of, if I were to summarize it, is just DFA, NFA, and regular expression. All right, all regular type stuff, all right? In particular, you should know just basic things like I give you a set and I say, make me a DFA that generates this, or make me an NFA, or make me a regular expression. Or we could go the other way around. I show you an NFA, and you tell me what the language it generates are. All right. You should also be able to convert from one to another. Right. We talked specifically about how to go NFA, convert it into a DFA. That's actually the subset thing, which you did on the quiz. And then converting back and forth NFA and regular expressions is what we did. Well, it's on the homework that's due today. We talked about that last time and the time before. One thing we never talked about, we didn't talk about actually converting a regular expression directly to DFA or the other way around. And we never talked about that. If you really had to do that, I would say convert the regular expression to NFA first, and then convert NFA to DFA. Although it may be easier to just think about what the language of the regular expression is, and then just from scratch create a DFA that has that same language. Although if you wanted to follow our procedures, you could do it sort of in 2 steps. Yeah?
Did we also convert DFAs to NFAs at one point?
Actually, we never talked about how do you convert a DFA to an NFA. There's kind of a reason why we never discussed that. You have any thoughts about that? If I show you a DFA and say, make me an NFA that does the same thing. Yeah.
Because every DFA is an NFA.
Yeah, like it already is an NFA. It has no epsilon transitions and it has no extra arrows. So that's not really a thing to convert DFA to NFA. It sometimes is possible to simplify the machine by, like an NFA, which does the same thing as a DFA, might be smaller, but it's not really a conversion. Anyway, you should be able to convert from one to the other. Also, you should know various constructions to make union and intersection, and I just write that. For DFAs, we talked about union and concatenation for NFAs. And we talked about, that's it, I guess. For instance, if I show you 2 DFAs and say, give me a DFA which has the language of the union or the intersection, that was called the product construction, where you make a big DFA, all of whose states are pairs of original states. You probably remember that, or maybe you don't, but you could refresh your memory. This is the product machine. And then the unions and concatenation things were the, plugging the NFAs together either by splitting 2 parallel tracks or putting them one after another to get the concatenation. You should also know the formal descriptions of the NFA, DFA, formal descriptions of NFA and DFAs. delta, the delta star, etc. Remember the delta and the delta star? And then these are really all the major topics that I could think of to put in a list of topics. Nothing about derivatives. So that's the end of the material is really when we talked about converting back and forth NFA and regular expression. That's where we go up to. Anybody feel like I left anything out or have questions? I mean, we can do examples of any of these things if you'd like to. Refresh your memory about this or that. Yes?
What's the format of this?
Oh yeah, I was going to say, you should expect the test questions to be similar to the homework and quiz questions. I'm going to, actually like print out the test on paper and hand it out so you don't have to do this screening thing. You should expect it to be something like 4 of our quizzes. We're going to have the whole class period to do it, and you'll send it to Gradescope at the end in the usual way. So hopefully nothing too wild and crazy. No scantrons. What else? Yeah.
I know at one point we proved subset construction, proved a few other things. Are there going to be proofs on those tests?
No, not like that. And I can't think of any other thing that I would ask you to prove. So no. We are going to use derivatives to prove things eventually, but not for this material. What else? If there really aren't any questions, we can just continue talking about derivatives. Although I want to give us some time if there are questions. Yes?
Could you just give an example of concatenation for NFA?
Sure. Concatenation for the NFAs. You might use this. I mean, I could just tell you directly to concatenate 2 NFAs together, in which case there's not a lot to it. But you might use this to do something like, here is a language. Let's say it's the language of A, B, X, A, Y, such that X equals A to the N, and Y has even number of B's. All right, this is a kind of strange language. It says this is all the strings which start with A, then B, and then they have something which is like A to the N, and then they have A, and then they have Y. Is that overly complicated? It's a little strange, but we can handle it. What I would like to do is I want to make an NFA for L. All right. And I'm going to think of this as a concatenation because it has, actually, this is going to be, I think I've overcomplicated matters. Can we just scribble out, let's just scribble out this and this to make it even easier. Maybe we'll talk in a moment about how you could reinsert those if we wanted to, but let's start with this. Just A to the N followed by something which has an even number of B's. My basic idea is going to be, let's make an NFA for the X part, and then also make another NFA for the Y part, and then jam them together to get the NFA for the whole thing. So the X part is just A to the N. How would you make an NFA that does that? Accepts just A to the power N? Yeah. Just a single state with an A. Great. So if you ever see a B, you get stuck and it's rejected. But if you see nothing but A's, then it's accepted. Okay, and then the Y part. Y has an even number of B's. Anybody want to suggest how we would do that? This is slightly more complicated than the X part, I guess. Yeah.
It would just be two states, and
Uh-huh.
the first one is accepting, and there's a arrow going to both of them, like back and forth.
Yeah, that sounds great. Kind of great. Actually, we need a little bit more than that. Yeah, this one accepts only b to some even power, right? This does not allow for any a's. If I wanted to also allow for a's, like any a's, because all I care about is even number b's, but it has some a's in it, presumably, then you would just insert two looped a's. This allows you to do a's whenever you want. The total number of b's has to be even though. All right, anyway, I want to concatenate these two, so I think of these as sort of two boxes, and I'm going to stick them together like this. This is how we do the concatenation. You go from the accepting states of the first box and plug them by an epsilon transition into the accepting states of the second box. So what that would look like is, so the final answer would be, this is my original starting state for the X part, which has this loop A. Now I'm not going to make it accepting anymore because in order to be accepted it has to go through both parts. But anyway, it's that, and then followed by an epsilon transition into the second machine. And here I really am going to make this one accepting. Like so. And that's my final answer. All right. This is how you concatenate two things, and this can be a useful tactic. You know, if I show you a description of a language which is fairly complicated, but it involves some concatenating, you can use this to kind of think about it more clearly, break it down into the two pieces, and then stick them together at the end. All right. What if I actually did introduce those extra things that I scribbled out? How about same thing, but with the I had a, b, x, a, y, such that same business. How would we do that? Well, I would just concatenate an extra a and b on the front and an extra a sort of in the middle in between the x and the y. So it would look like, here's my extra a on the front followed by an extra b on the front, and then I go into this state, which, remember, this part was doing the x part, right? I put the extra a and b on the front. Then after that x part, I put another little a, all right? I suppose I didn't really need that epsilon to be there. This could be condensed a little bit, but an extra a after the x part, and then it goes into the y part. Like so. So that's the whole answer. This can be simplified. Those epsilons in the middle with the a there could all be collapsed into a single edge with the a on it, if you wanted to. Anything else to discuss? Yeah.
Could we just go with the product construction?
Sure. Yeah, that was kind of a big thing that we haven't done in a while. It's not super hard, but you got to remember how to do it. This is how you take two DFAs and combine them together, either getting the intersection language or the union language. Let's try to make a DFA for L of M1 intersect L of M2, where I'll give you two machines here. I'm just going to make this up. Hopefully it'll be interesting. Let's put a B there. How about that? All right, that's M1, M2. I'll just have two states. this one is accepting. I think that's legal. When I do the product, I could have at most 8 states. I hope I don't actually need all 8 states, but we'll see. Yeah.
For the acceptance statement M1.
Oh, I need some more arrows there. Yeah, thanks. Let's say, like, let's just loop them. A, B, like that. Any others I missed? I don't think so.
The tops.
Yeah. Okay. Let's do the product construction to make the intersection. So what we got to do is, I'm going to give names to all these states. I made the circles a little too small, sorry. Let's just call these S, T, U, V, like that, and X, Y over here. All right, so my starting state in my combined machine is going to be S, comma, X, right? You just combine the 2 starting states from each of your original 2 machines. And then I'm going to draw some arrows. So the A arrow from SX, anybody remember how to do this? Where's it going to go to? TY. Yeah, you look, where does the S go when I do A? It goes to T. And then where does the X go? It goes to Y. So SX, when I do A, goes to TY. And so on. You got to do enough arrows until you stop generating new states. So SX with a B, S goes to U, X goes to X. So it's going to go to UX. All right. I will decide at the end which ones are accepting and which ones are not accepting. Let's continue from TY. I'm going to try to draw this so that the A arrows point roughly horizontally and the B arrows point roughly vertically. I have no idea if that's going to work out. The TY, when I do A, T goes to V, Y goes to Y. So this goes to V, Y with the A, I think. And TY with a B, T goes to V, Y goes to X. So that goes to VX with a B. All right, I'm just getting new states every time, which I don't like. From VY, when I do A, V goes to S, Y goes to Y. That's SY. All right, this is another new state. Maybe I am going to have to use all 8 of them. I don't know. VY with a B. V goes to U. Y goes to X. That's UX. All right. I got to cross the arrows here. Sorry. I'll just do that. I don't like the looks of that, but it's all right. Everybody following what we're doing, I hope? Okay, S, Y, let's do that one. S and Y. When I do A from S, it goes to T, and Y stays at Y, so that goes to TY. Okay, I can do that. And SY with a B. S goes to U, Y goes to X. It goes to UX, all right? Maybe I'll just join that one here. Look at that beautiful picture. All right, get the photo shoot over here. UX. Let's draw arrows from UX. When I do A, it stays at U, and when I do A for X, it goes to Y. So that goes to UY with an A. Okay, I'm gonna have to draw a new state for that. Maybe I'll put it down here. I don't know. That's an A. And UX with a B. U stays with U, X stays with X. So that's good. All right. We must be almost done. This can't get all that worse. Let's do VX. With an A goes to, the V goes to S, and the X goes to Y. So it goes to VY, like that. And VX with a B goes to, V goes to U, X goes to X. So all right, that wasn't so bad. And then UY with an A. U goes to U, y goes to y, so that's a loop. And with a b, u goes to u, y goes to x, so that's ux. Okay, I guess I should have put that one over there. And I think that's it. We never had to use one of them. sy. No? Sy is there. Which one didn't we use? tx. No. Yes, tx is not on it. All right.
Vx with a go to sy.
Say that again?
Vx, it's like the middle state.
Yeah.
Shouldn't it go to sy instead of
Vx with an A. Yes, you're right. Sy. Okay. Thank you. Yes, I'm sure there's a much better way to draw this diagram, but what are the accepting states? Now, you have to remember, here's the only time it matters. I said intersection here rather than union. So to do the intersection, the accepting states would be all the ones which have part of the pair accepting in the first part and also accepting in the second part. There's only one state like that, it's ux. So to get the intersection, I use ux as the only accepting state. If you wanted the union, you would use all the things which are accepting on the first one or accepting on the second one. That would include everything with a u in it and also everything with an x in it, which down here would be almost all of them. Well, no, not almost all of them. Everything with a u or an x. I'll draw those in red. That would be this one, this one, this one, and this one, right? So if you wanted the union, you would use the red ones as the accepting states. If you wanted the intersection, you would use only u comma x. All right. What else can we talk about? We got 10 more minutes. I got another way to make the union. If I didn't say you have to use, how about this? This is actually much easier. What if I wanted an Nfa for the union? Now you could make the DFA and call it an NFA. That would be correct, although not the easiest way. What if I said find me an NFA for the union? Yep.
You just use or, so you have like a starting state and then you branch off into
Yeah. So to get an NFA for the union, come on. Sorry. NFA for L of M1 union L of M2, you could just do this thing. And then paste those two diagrams exactly as they are. So this one here. And then this one up here. I don't. Something like that, right? This is an NFA for the union. Although NFA for the intersection, there is no simple trick to do that. You basically, well, I guess the easiest way to do the intersection, even on an NFA, would be this kind of thing. Yes?
That's an intersection, right? It's not a union, so there should only be one acceptance.
Yes. Yeah, so I was drawing in these red ones. I was trying to sort of indicate them both in the same picture. The red ones indicate the accepting states if you were doing the union, and the intersection would be only this one here. Yeah. Yes?
Could you also consolidate the accepting states to that union effect in this particular?
Down here?
Yeah.
Yes. You mean make it into only one accepting state?
Yeah.
Yeah, if you wanted to, you could. You would just make an accepting state over here, and then tie epsilons like that. Yeah, if you wanted to have it have only one accepting state, and then you could make these not accepting anymore, and it would be equivalent, because you could just do the epsilons to get to accepting. Mm-hmm. What else? We got 5 more minutes.